Let's work on another problem. X sine x cosine x from 0 to pi integrated with respect to x. Now, we have learned integration by parts. There usually are two functions. Here we are having three functions, x sine x, cosine x. So we don't really have any technique to do that. So I'm gonna do a little bit manipulation. In trig, you must have learned the double angle formula. Sine 2x is equal to 2 sine x cosine x. Okay, if you notice, this part is same as this part. That means sine x cosine x can be written as basically sine 2x by 2. So I'm doing that first before even thinking about integration by parts. X, this part I'm writing as sine 2x by 2. By 2 goes out, dx. Now it's two functions. I can start thinking about integration by parts. There is x, which is algebraic function, and there is sine 2x, which is trig function. So x comes first. That means u will be x, and the remaining function attached with dx will become dv, sine 2x dx. Okay. We are going to differentiate. X's derivative is 1, so it's just going to be dx. dv part we are going to integrate, so v is equal to, what is the formula for integral of sine ax? That is negative cosine ax by a plus c. Here you don't have to write c in our question because we are just finding v here. Sine 2x's integral is negative cosine 2x by 2. Okay, let's write our integration by parts rule. U dv is equal to uv minus integral v du. Okay, so our integral half is out. U is x times v is this, so that becomes negative cosine 2x by 2 minus integral v. This is also negatives. Two negatives make it positive. Cosine 2x by 2 I'm going to write out, and du is just dx. But remember, this was a definite integral problem. That means this part is already solved, so I have to write the limits on the left hand side. But here integral is still on, so I have to write limits here. So limits were 0 to pi. Okay. This first part we can actually put in the limits. This 2 and 2 is negative 1 by 4. I can just write it out to make my life easier. Negative 1 by 4. When I put pi in this, pi cosine 2 pi minus, when I put 0, 0 times cosine 0. Okay. Plus half. What is the integral of cosine 2x? That is sine 2x by 2. But now we have to put limits from 0 to pi. Okay, let's write this down. Negative 1 by 4. Cosine 2 pi is 1. So that's just pi. And this thing is just 0. Plus half. I need to put upper limit. So sine 2 pi by 2 minus put 0. Sine 0 by 2. This thing is just 0 and this thing is also just 0. So my final answer is negative pi by 4. Let's do a different kind of a problem. This is integral of natural log of x power n. Okay. In these kind of questions, we are not actually, because n is not given, we are trying to create integration formula of a sort. Okay, you will see it at the end. Just to start, I'm gonna name this as IN. I stands for integral, N stands for because there is a N here. Okay. So just name it IN. But let's try to work it out using integration by parts. Again, this function only has one function in here, natural log of x power n. There is nothing else. So to manipulate another function, I just write 1 here. Okay. Now let's go over natural log of x power n is a log function, and 1 is an algebraic function. Natural log of x power n comes first in our Li8 list. So that means u will be named as natural log of x power n, and the remaining 1 dx would be named as dv. Okay. We are going to differentiate u. What is it? Chain rule. Remember, n is outside, n is a power is an outside function. N comes down, natural of x power n minus 1 times the derivative of natural log of x is 1 by x dx. And for dv, you're going to integrate to get to v. Integral of 1 is just x. Our integration formula here is integral u dv is equal to uv minus integral v du. That means my in, which I named original integral, is u. U is ln x power n times v, which is x. I'm going to write in the front. It looks nicer. Integral v. V is x times du. Du is this whole thing. So you're going to write ln x power n minus 1. N is a constant. I'm going to write outside by x dx. If you notice, this x cancels out. What are we left with? X natural log of x power n minus n integral of natural log of x power n minus 1 dx. Where did we start from? We started from natural log of x power n dx, and I named that, if you remember, I said name it in because the power n is here, right? If you notice, this thing is exactly same as this, except n place of n there is n minus 1. So I'm going to write this one more time, see if you understand it. This part I'm just copying, and I'm just copying. But this integral, I'm going to name it in minus 1. So it's the same integral, but now in place of n we have n minus 1. So in is equal to x times natural log of x power n. That part is already solved, minus n times in minus 1. So this is kind of what this is called reduction formula for integration, where it's like if you have, say, natural log of x power 3, you are reducing the power 1 and then 1 again and 1 again, and finally you'll be able to solve this question, right? So you have to find in minus 1 again using the reduction formula, and so at the end you get the answer. So this is a special kind of a problem for reduction formula for integration.